Section 2.3, shifting gears. Manual transmissions, multi-speed rear axles, and auxiliary transmissions, and automatic transmissions. Key elements of shifting. Shift by the tachometer. Downshift when engine speed approaches low range of governed speed. Avoid lugging. A variety of RPM and gear shift patterns. Learn RPM and shift patterns of the vehicle you drive. Match engine speed RPMs to transmission speed. Shift smoothly to avoid clashing gears. Shift by the tachometer. Upshift when engine RPMs approaches the top of the governed speed. Avoid overspeeding. Downshift when the engine speed approaches low range of governed speed. Avoid lugging. A variety of RPM and gear shift patterns. Learn RPM shift patterns for the vehicle you drive. Shift controls. There are three. We have the gear shift lever, we have the clutch, and we have the accelerator. The accelerator controls fuel to the engine. Clutch controls the connection between engine and transmission. Gear shift lever allows driver to select gears in the transmission. Clutch brake operation. The clutch brake is operated in a non-synchronized transmission, stops or slows down the main shaft, aids in getting the vehicle in gear without damaging the gears. The clutch brake has three phases. It has free play, working, and clutch brake. Ground speed and gear. Examples of specific gears to ground speed relationships for a 9-speed transmission. Progressive shifting. This is shifting before you reach the governed RPM, allows you to take the most advantage of the engine's power, and saves fuel also. Eaton-Fuller 9-speed transmission. High and low range operation. Low range is low gear through 4th gear. High range is 5th gear through 9th gear. Range control lever to the switch between ranges. Standard H pattern for each range. Rockwheel 10-speed transmission. High and low range. Low range is 1st through 5th gear. High range is 6th through 10th gear. Standard H pattern for each range. Eaton-Fuller 13-speed transmission. High and low range operation. Low range, low through 4th gear. High range, 5th through 9th gear. If you notice, 5th, 6th, 7th, and 8th have a direct and an overdrive. Fully automatic transmission. Gear positions. Neutral, used when starting and standing and parking. Reverse, vehicle must be completely stopped before using. 2 through 5 are drive at normal driving conditions. 2 and 3, 2 and 4, low range for load types, driving conditions. 2 when pulling through mud, snow, and up steep grades. And 1, creeper gear for off-highway use. Study section 2.3, shifting gears. Question 1. What are the 2 special conditions where you should downshift?
Before starting down a hill, slow down and shift down to a speed that you can control without using the brakes hard. Otherwise, the brakes can overheat and lose their braking power. Downshift before starting down the hill. Make sure you're in a low enough gear, usually lower than the gear required to climb the same hill. Before entering a curve, slow down to a safe speed and downshift to the right gear before entering the curve. This lets you use some power through the curve to help the vehicle be more stable while turning. It also lets you speed up as soon as you're out of the curve.
Question 2. When should you downshift automatic transmissions?
Automatic transmissions. Some vehicles have automatic transmissions. You can select a low range to get greater engine braking when going down grades. The lower ranges prevent the transmission from shifting up beyond the selected gear, unless the governor RPM is exceeded. It is very important to use this braking effect, downshifting, when going down grades.
Question 3. Retarders keep you from skidding when the road is slippery. True or false?
False. Some vehicles have retarders. Retarders help slow a vehicle, reducing the need for using your brakes. They reduce brake wear and give you another way to slow down. There are many types of retarders: exhaust, engine, hydraulic, electric. All retarders can be turned on or off by the driver. On some, the retarding power can be adjusted. When turned on, retarders apply their braking power to drive wheels only whenever you let up on the accelerating pedal all the way. Caution: when your drive wheels have poor traction, the retarder may cause them to skid. Therefore, you should turn the retarder off whenever the road is wet, icy, or snow-covered.
Question 4. What are 2 ways to know when to shift?
There are 2 ways of knowing when to shift. Use engine speed, or RPM. Study the driver's manual for your vehicle and learn the operating RPM range. Watch your tachometer and shift up when your engine reaches the top of the range. Some newer vehicles use progressive shifting. The RPM at which you shift becomes higher as you move up in gears. Find out what's right for the vehicle you will operate. Use road speed, MPH. Learn what speeds each gear is good for. Then, by using the speedometer, you'll know when to shift up. With either method, you may learn to use engine sounds to know when to shift.
Section 2.4, Seeing. City driving. 12 to 15 seconds is about 1 block. This allows you enough time to identify problems, prepare for trouble, decide how to avoid problems, check mirrors before changing lanes, take the correct action. On the open highway, it's the same 12 to 15 seconds, but that equates to about 1/4 of a mile. That once again gives you enough time to identify a problem, prepare for trouble, decide how to avoid a problem, check mirrors before changing lanes, take the correct action. All good kids like milk. A, aim high in steering, 1 city block in town, 1 mile deep on the highway. G, getting the big picture, stay away from billboards and following too close. K, keep your eyes moving, check the front, side, rear gauges, repeat every 10 seconds. L, leave yourself an out, drive defensively, anticipate where you'll go if something happens. M, make sure they see you, communicate in traffic using ears, eyes, horns, lights, and signals. Your field of vision using a flat or plane mirror, the bigger field of view in the left mirror, best view of the rear of the trailer and roadway behind, however it can leave blind spots. The field of vision using a convex mirror, the curved to a wide angle view, best used to side close-ups, eliminates most but not all blind spots. Objects in the mirror are closer than they appear. You must be sure and have the convex and plane mirror overlap. Combination of the plane and convex mirror provides the best side and rear vision. Still need to check your mirrors for objects in blind spots. Field of vision when making a right turn. Notice the car in the convex mirror view. The plane mirror view does not allow you to see behind. Distortion of convex mirrors. The plane mirror has a much larger vision. The convex mirror shows that the vehicle is further away than it really is. Checking to sides and rear. Check mirrors several times a minute. Be especially alert at intersections, shopping centers, construction sites, and school zones. 2.5, communicating. Signal your intentions, communicating your presence. Signal early, signal continuously, and cancel your signal after you have turned. Changing lanes. Check traffic to the front and rear. Signal the lane change. Do not tailgate. Make a smooth lane change. Maintain your speed. Allow correct distance between all vehicles and cancel your signal. Overtaking other vehicles. Assume they do not see you. Signal your presence. Light tap on the horn. Flash your lights. Roadside emergency equipment that is needed. We have fire extinguisher, triangles, and fuses. Stopping off the road. Turn on the emergency flashers. Place reflective triangles to give others advance warning. Use flares or fuses at night for better safety. Do not use flares or fuses if carrying hazardous materials or if there is a spilled fuel. Two-way or divided highway. Place the first triangle 100 feet in front of the vehicle. Place the next one 10 foot behind the vehicle. Place the third one 100 foot behind the vehicle. One-way or divided highway. Place the first triangle 10 feet behind the vehicle. Place the second 100 feet behind the vehicle. Place the third 200 feet behind the vehicle. Obstructed views. We want to make sure that you get over the hill or around the curve. You're allowed to place the first one 10 feet behind the vehicle and the second one 100 to 500 feet behind the vehicle. Same on curves. 2.6, controlling speed. Speed and stopping distance, matching speed to the road surface, speed and curves. How far will the rig travel in 1 second? If you're doing 15 miles per hour, you travel 22 feet per second. Perception time and reaction distance is 38.5 feet. The driver reaction distance is 17 feet. The vehicle braking distance is 29 feet. Total stopping distance is 46 feet. Let's assume you're being a very, very good truck driver and you're in a school zone. Most school zones have 20 mile per hour speed limits. So here comes the ball bouncing out from the playground. Well, you're being a good driver, you're only traveling 15 miles per hour. You better hope that you have at least 46 feet between you and that bouncing ball. Now let's look at 55 miles per hour. We're traveling 81 feet per second. The perception time is 141.2 feet. The driver reaction time, that is the time it takes you to get your foot off of the accelerator onto the brake, is 61 feet. Vehicle braking distance, 390 feet. Total stopping distance, 451 feet. That's a football field and a half. Hydroplaning. Tires not touching the road. Get off the accelerator. Gradually deaccelerate. Do not brake and do not turn the wheel. Center of gravity. Load cargo to keep center of gravity as low as possible. Reduce speed as the center of gravity rises. The higher the center of gravity, the more likely the rig is to turn over during turns. Effect of speed on sight distance. At 40 miles an hour, you need 250 feet to stop the vehicle. Your sight distance is 250 feet. At 50 miles an hour, your stopping distance is 375 feet. However, your sight distance is still 250 feet. In the example, you would push the car down the road an additional 125 feet. Speed management. Adjust for road conditions. Be able to stop within the distance you can see ahead. Go with the flow of traffic whenever possible. Drive within your comfort zone. Study Section 2.4, Seeing, Section 2.5, Communicating, Section 2.6, Controlling Speed. Question 1. How far ahead does the manual say you should look?
How far ahead to look? Most good drivers look 12 to 15 seconds ahead. That means looking ahead the distance you will travel in 12 to 15 seconds. At lower speeds, that's about 1 block. At highway speeds, it's about 1/4 of a mile. If you're not looking that far ahead, you may have to stop too quickly or make quick lane changes. Looking 12 to 15 seconds ahead doesn't mean not paying attention to things that are closer. Good drivers shift their attention back and forth, near and far.
Question 2. What are two main things to look for ahead?
Look for traffic. Look for vehicles coming onto the highway or into your lane or turning. Watch for brake lights from slowing vehicles. By seeing these things far enough ahead, you can change your speed or change lanes if necessary to avoid a problem. Look for road conditions. Look for hills and curves. Anything you'll have to slow or change lanes for. Pay attention to traffic signals and signs. If a light has been green for a long time, it will probably change before you get there.
Question 3. What's your most important way to see to the sides and to the rear?
Seeing to the sides and rear. It's important to know what's going on behind and to the sides. Check your mirrors regularly. Check more often in special situations. Mirror adjustment. Mirror adjustment should be checked prior to the start of any trip and can only be checked accurately when the trailers are straight. You should check and adjust each mirror as needed.
Question 4. What does communicating mean in safe driving?
Communicating your presence. Other drivers may not notice your vehicle even when it's in plain sight. Let them know you're there to help prevent accidents.
Question 5. Where should your reflectors be placed when stopped on a divided highway?
If you must stop on or by a one-way or divided highway, place warning devices 10 feet, 100 feet, and 200 feet toward the approaching traffic. Please refer to Figure 2-10.
Question 6. What three things add up to total stopping distance?
There are three things that add up to total stopping distance: perception distance plus reaction distance plus braking distance equals total stopping distance.
Question 7. If you go twice as fast, will your stopping distance increase by 2 or 4 times?
Whenever you double your speed, it takes about 4 times as much distance to stop, and your vehicle will have 4 times the destructive power in a collision. High speeds increase stopping distances greatly. By slowing down a little, you can gain a lot in reduced braking distance.
Question 8. Empty trucks have the best braking. True or false?
False. Empty trucks require greater stopping distances because an empty vehicle has less traction. It can bounce and lock up its wheels, giving much poorer braking. This is not usually the case with buses.
Question 9. What is hydroplaning?
Hydroplaning. In some weather, water or slush collects on the road. When this happens, your vehicle can hydroplane. It's like water skiing. The tires lose their contact with the road and have little or no traction. You may not be able to steer or brake. You can regain control by releasing the accelerator and pushing in the clutch. This will slow your vehicle and let the wheels turn freely. If the vehicle is hydroplaning, do not use the brakes to slow down. If the drive wheels start to skid, push in the clutch to let them turn freely.
Question 10. What is black ice?
Black ice. Black ice is a thin layer that is clear enough that you can see the road underneath it. It makes the road look wet. Anytime the temperature is below freezing and the road looks wet, watch out for black ice.
Section 2.7, managing space. The space ahead, the space behind, space to the sides, overhead, below, and turning. Space cushion in the front of the vehicle, to the left, to the right, to the back, above, and beneath. Following distance, 40 miles per hour, 1 second for each 10 foot of vehicle length. Over 40 miles an hour, 1 second for each 10 feet of vehicle length, plus 1 second. Adverse conditions, add another second. Below 40 miles an hour, 4 seconds in the example. The vehicle is 40 foot in length from the front bumper to the rear bumper. That's 4 seconds. In this case here, it is 60 feet in length, so that would be 6 seconds. Changing lanes, leave plenty of space. Be sure you have cleared the vehicle you are passing. Do not trust signals of other drivers. Tailgaters, reduce speed slowly, avoid quick changes, increase following distance, do not flash lights. Space overhead, watch for low-hanging wires, marquees, signs, overhead structures, bridges, and overpasses. Space below, watch for railroad tracks, soft surfaces, parking lots, unpaved surfaces, excavated areas. Right turn, approach in the right lane, turn on the right turn signal, swing left, and turn sharply to the right. Remember that the rear wheels do not follow the same path as the front wheels. Rear wheels follow a shorter path than the front wheels. The more distance between the front and rear wheels, the greater the off-tracking. Jug handle. There's little or no advantage gained by doing a jug handle. The trailer tires do not move any further away from the curb, crossing into oncoming traffic and confusing drivers behind you, signaling right, but the vehicle's initial move is left. The correct way to make the turn is a button hook. Errors in making right turns. Number one, approach the intersection too fast. That is the number one problem. Not being in the proper gear before starting the turn, shifting gears while turning, not allowing for off-tracking of the trailer, not getting far enough into the intersection before making the turn. Making a left turn. Slow down as you approach the intersection. Put the vehicle into the right gear before the turn. Keep your wheels straight. Be as far to the right in the left lane as you can. Watch the left mirror during the turn. After turning, turn the steering wheel back to the right to straighten the wheels. Cross or enter traffic. Rigs need a larger gap in traffic than cars do. The heavier the vehicle, the slower the acceleration. Be absolutely sure there's enough room to complete the maneuver safely. Remember, you're not driving a Ferrari. Study section 2.7, managing space. Question 1. How do you find out how many seconds of following distance you have?
One good rule says at least 1 second for each 10 feet of vehicle length at speeds below 40 miles per hour. At greater speeds, you must add 1 second for safety. For example, if you're driving a 40-foot vehicle, you should leave 4 seconds between you and the vehicle ahead. In a 60-foot rig, you need 6 seconds. Over 40 miles per hour, you need 5 seconds for a 40-foot vehicle and 7 seconds for a 60-foot vehicle. To know how much space you have, wait until the vehicle ahead passes a shadow on the road, a pavement marking, or some other clear landmark. Then, count off the seconds like this: 1001, 1002, and so on, until you reach the same spot. Compare your count with the rule of 1 second for every 10 feet of length. If you're driving a 40-foot truck and only counted up 2 seconds, you're too close. Drop back a little and count again until you have 4 seconds of following distance, or 5 seconds if you're going over 40 miles per hour. After a little practice, you'll know how far back you should be. Remember to add 1 second for speeds above 40 miles per hour. Also, remember that when the road is slippery, you need much more space to stop.
Question 2. If you are driving a 30-foot vehicle at 55 miles an hour, how many seconds of following distance should you have?
Four seconds. One good rule says at least 1 second for each 10 feet of vehicle length at speeds below 40 miles per hour. At greater speeds, you must add 1 second for safety. For example, if you're driving a 40-foot vehicle, you should leave 4 seconds between you and the vehicle ahead. In a 60-foot rig, you'll need 6 seconds. Over 40 miles per hour, you'll need 5 seconds for a 40-foot vehicle and 7 seconds for a 60-foot vehicle. To know how much space you have, wait until the vehicle ahead passes a shadow on the road, a pavement marking, or some other clear landmark.
Number 3. You should decrease your following distance if somebody is following you too closely. True or false?
False. Increase your following distance. Opening up room in front of you will help you to avoid having to make sudden speed or direction changes. It also makes it easier for the tailgater to get around you.
Question 4. If you swing wide to the left before turning right, another driver may try to pass you on the right. True or false?
True. Don't turn wide to the left as you start the turn. A following driver may think you're turning left and try to pass you on the right. You may hit the other vehicle as you complete your turn.